Yay. Okay. Happy Thursday. We are Thursday, week 6. We're past the halfway point, finishing up chapter 7, and then all we'll have left is 8, 9, and 10. As a reminder, the test opens Tuesday. It covers 5 through 7. I Statistically, test 2 has better grades than test 1. I don't know though, because the median for this last test was pretty darn good. The mean was a little bit low, but the median was pretty darn good. So, um, who knows? Who knows? Every term I get surprised a little bit. So I'm excited to see how that goes for everyone. I'm going to say this at the beginning because not everyone watches to the end. Next week, so we do have office hours, but I have to move office hours earlier. So my option was either to not do office hours at all or move it early because I have to present at a scholarship night for my high school students that night. So the office hours will be 4 to 5. I know some of you work and everything, but I will make sure that I'm answering questions through through messages. I'll make sure to check over the weekend more frequently and do the best I can to be available. But I need to be able to present things to my seniors at scholarship night. So from 4 to 5, I will have office hours. Just drop in and you can ask questions if you're able to. So 4 to 5 on Tuesday will be office hours. Just drop in. And I'll remind you on Sunday and I'll put a notice in like right on the screen where you click on the link for this Zoom meeting. All right. So that's that information, and we'll get going. Today we're going to do 7.2. We're finishing up chapter 7. We're going to actually, we talked about what the area under the curve meant in 7.1. We're actually going to find it in 7.2, find that area, and then use the interpretations we learned in 7.1. We're also going to work backwards. So given an area or a probability, we will find the actual data value that goes with that area or probability. So those are the two things we're going to do tonight. It's not going to take very long, probably slightly longer than it took on Tuesday. It's a pretty short class. And then we'll be good to go for the weekend and you'll be able to do your homework. So let's get going. Okay. So we talked about z-scores before, and you all know basically what z-scores mean. Sometimes we use them to standardize a normal variable. So you might recall back when we were comparing heights of basketball players, and we were comparing the number of runs from the national baseball and American baseball. So the two different leagues, we were comparing those. So sometimes when we're comparing two things that are two different populations, it's like comparing apples to oranges. You're going to see in your homework that they use the ACT and the SAT. They're two standardized tests, but they score very differently. So in order to compare how well you did on both tests, if we convert all of the data values to z-scores, it makes it a lot easier to compare them. So that's what it means when we standardize a normal random variable. So you just take all the outcomes of the variable, subtract the mean, and divide by standard deviation. It's exactly the same. This is just what we do. You're basically doing it with all the data values, but you're not going to have to go through a whole data set and do that with each one. So don't worry about that. So we frequently will standardize our data so that we can get a better idea of where we are in comparison to other things. Okay, so IQ scores can be modeled. They have a normal distribution with mean of 100, standard deviation of 15. So we're just finding what the z-score is of the IQ of someone with 120 or of an IQ score of 120. So when we calculated the z-score, we get 1.33. So a person with an IQ score of 120 has a z-score of 1.33. So you may not have known if somebody just told you, oh yeah, they have a 120 IQ. You wouldn't really have any idea of what that means. But knowing it has a z-score of 1.33, you can determine that it's a little bit above average. So it's not an outlier. It's not extremely above average, but it's actually a decent amount above average because it's outside that 68%. It's in between the 68% and the 95% if you're thinking about the empirical rule. So it kind of gives you an idea of where that would be located on the normal curve. So this is why we standardize things because it puts it in terms that we can understand. It's kind of like if somebody was talking about, you know, in America anyway, we don't use kilometers a lot. We tend to use miles. Somebody talking about kilometers a lot, it might not be as meaningful for you. So if we converted it to miles, that would be more meaningful to people who don't use kilometers a lot. Or Celsius, converting it to Fahrenheit so that we can understand it. So Z-score is like a universal language that everyone can understand. So that's why we convert things to Z-scores. Does that make sense? All right. So on our Z table, so the Z table, it is located. You probably saw this. You may or may not have seen this. So the Z table is located right here above week 3. I'm going to move it down. I'm going to move it down because I think it's also in this week. I'm going to move it down right above week 6. I think it's also, yeah, it's also in week 6. So this is what the Z table looks like. So if I know a Z-score, I can determine the area of the curve to the left of that Z-score with this table, because that's going to tell me that if I randomly selected a person, what's the probability that their IQ is less than or equal to 120, or the proportion of people whose IQs are less than or equal to 120. So this will tell us that. So it shows a Z table here. Oops. This Z table looks kind of different than ours, but not terribly different. So you're going to go down the left side. This gives you the whole number and the tenths of the Z-score. So we're looking for 1.33. We're going to go down the side till we see 1.3, and then you go over to the column that's 0.03, and you will see 90.82% of all people have an IQ of less than or equal to 90 or 100, 120. I forgot the number for a minute. I'm going to show you on our Z table. Our Z table starts at negative 3.4 and it goes to positive 3.4. So if I go to 1.3, I need to make this a little smaller so I can see where 0.03 is. 1.3, and I'm going to go over to 0, 1, 2, 3. So right here, it's 0.9082. So 90.82%. This little diagram here reminds you that this gives us the area to the left. So if I wanted to know what the probability is of a randomly selected person having an IQ above 120, I would have to subtract 0.9082 from 1. I'm going to do that on my paper or my iPad. 0.9082. Pop over here. 1 minus 0.9082 is 0.0918. So if I randomly selected a person, about a 9.2% chance that their IQ would be greater than or equal to 120. Questions so far? All right, let's move on. This is a picture of your I already did this math because I get excited about the math sometimes. This is a picture of our normal curve, and it shows this area right here is below that 1.33 or below the 120 IQ score. The one standard deviation away is 85 to 115, so we're a little bit above that. 2 standard deviations away would go up to 130, so we're, a little closer to the 1 standard deviation, but we're in a pretty good shape. That's still a really nice IQ. And if we were looking for the complement, we're looking for the probability greater than or equal to. Here's that math that we just did. All right. So we have a calculator function, and I'm going to do this calculator function 2 different ways for you. I'm going to do that with z-scores, and I will do it with actual data values. We're going to start with z-scores. So I've already used Binom PDF, and we've used binom CDF. We never use normal PDF. I've never used it. I don't anticipate ever using it. We only use normal CDF. Now I'm going to go to my calculator and we're going to do the same calculation we just did. I'm going to pop over here. That's the wrong side. So here's my lovely calculator. Okay, I'm going to do second vars, and normal CDF is your second number. I'm going to go down here to the second number, and I'm looking for the less than or equal to, I'm going to clear this, less than or equal to the z-score of 1.33. So what we do when it's less than or equal to is it's a number, basically, I'm going to show you this again. So it says negative 1e99. Basically what this is this is negative 1 times 10 to the 99th power. So this is a very, very, very small number. This number is super far negative. It might as well be infinity. That's why we use it. It is our version of negative infinity. So it's the smallest that we possibly can use. So in our calculator, this is scientific notation. So in our calculator, you're going to use this negative button here, and then 1. The E is located right above the comma. It says EE. You can see it right here. It says 2 capital E's. Use this one. Do not use the green one. It's not going to do any good for you. Use the EE right on the comma. So I do second EE and then 99. So this is saying that my lower bound, that's what this is here, my lower bound of the region I'm looking at is negative infinity. My upper bound is 1.33. Because I'm looking at less than or equal to the z-score of 1.33, that's going to be my upper bound. My z-scores have a mean of 0 and standard deviation of 1 every single time. If you're dealing with z-scores, you're going to have a mean of 0 and a standard deviation of 1 every single time. This is always the case with z-scores. So I'm going to hit paste right here. Give me a second. It pastes it in. So if you're on a calculator that doesn't have that lovely screen that I was just on, it's going to look like this. I'm going to write it on my iPad in a second. It's going to normal CDF, negative 1e99, comma, 1.33, comma, 0, comma, 1, and I'm going to hit enter. And this is the same thing that we got 0.9082. Obviously, with the calculator, it doesn't round things, so it goes out forever, but we only need those first 4 right there. Questions about the calculator? I am going to write it all down, but questions? Okay. And I know that it's already typed out on the screen, but I feel like saying it helps a little bit. So, and I'm going to do this example in just a second. So we are looking for the probability that we would randomly choose something below a certain number. So the way it is, so for less than or equal to, so a probability that our value is less than or equal to a certain z-score, we would do normal CDF, negative 1e99, then whatever your upper bound is, upper limit, upper bound, and I'm going to make this smaller and move it. I'm going to move this upper bound, and then it's 0, 0 and 1, this is the mean, and this right here is the standard deviation. So it's the lower limit when we're doing less than or equal to is negative 1e99, which is basically infinity, negative infinity. Our upper limit is whatever z-score we want as our maximum, and then mean is 0 and standard deviation is 1. So we're going to do this again with this one that they give us here. The probability of randomly selecting a person or whatever, a z-score, negative 1.2 or less. Pop right back to my calculator. So second vars, normal CDF. Lower is negative 1E99. My upper is negative 1.2. That's a 4. Don't know how that happened. 1.2. Our mean is always 0 with z-scores. Standard deviation is always 1 with z-scores. Hit on paste and hit enter. So that's the same number they got on the PowerPoint. It's about 11.5% of randomly choosing, or the proportion of our normal curve that has z-scores less than negative 1.2. Questions? We're going to do greater than in a second. Okay. So greater than, I'm going to also pop over on the table because we want to look at the z-score of negative 1.2. If I was there, negative 1.2, it's negative 1.20. So here's negative 1.2 right here, and the 0 column is right here. So you see that is the same number that we just got on our calculator, 0.1151. It's the same number. Usually, it's like I really like the elegance of the Z table. I really like it. And for less than, I probably will jump to a Z table. But if we're dealing with greater than, dealing with the Z table is okay, but you just have to do 1 minus. Dealing with your calculator is much easier. So I'm going to pop over to my other screen. So if we're doing to the right of a z-score, if we're doing greater than or equal to, if I was doing, uh-oh, that's weird. The probability that our random is greater than or equal to a certain z-score, then I would do 1 minus the probability is less than or equal to a certain z-score. This is how I would work. This is if I was using my z-table. If I was using my z-table, I would do 1 minus whatever I find in the z-table for that z-score. But thankfully, we have a lovely calculator, and our lovely calculator will do it without doing fancy schmancy stuff. We don't have to do that 1 minus or any of that. We can just jump straight to it. So here's what it's going to look like. So we want to look for the probability that we get a z-score greater than 0. Greater than or equal to, it doesn't matter. So let's take a look. First, I'm going to look at the z-table. The 0 is so easy because it's just 50%. A z-score of 0 is 50%. So 1 minus would be 50%. And that's kind of ridiculous they gave us that answer. So I'm going to jump to the calculator. Second vars, normal CDF. So my lower bound now is 0 because we're going greater than or equal to 0 or greater than 0. So my lower bound is going to be 0 and my upper is going to be positive infinity. So it's done the same way, but we're using a positive number instead of a negative. So it'll be 1. You do second comma to get the E and the 99. So that's our positive infinity. Z-scores, once again, we use 0 for mean and 1 for standard deviation. Actually, recording, yeah. Go down here to paste and hit enter, and then we'll get 50%. Yes, it says 0.499999995, but you get it. It's 50. Nobody's not going to round that to 50%. It is what it is. Sometimes our calculators are weird. I'm going to do another one with a better number. So here's the one with the better number. So this is a 1.3, really close to what we already had. So I'm looking probability a z-score is greater than 1.3. So my lower bound is going to be the 1.3. Upper bound is 1E99. My mean is 0 and standard deviation is 1 because it's z-scores. So go ahead and give that a shot. I'm going to wait for a second, then I'll do it myself. Did you get a 0.0968-ish?
Yes.
You did? Good. Any questions on this so far? We feeling okay? Feeling groovy? Calculator's so much easier than the Z-score. I mean, I love the Z-score, or the Z-table. I love the Z-table, but the calculator's just so much easier. And I highly recommend the calculator. It doesn't round anything, even though my open math is aware that you might be using the Z-table and you might be using your calculator. So 99 times out of 100, it's fine with either one. And pay attention though, because sometimes it'll say to round your Z-score to a certain number, like round it to the nearest hundredth. If you round it to the thousandth when it says to round it to the hundredth, it's going to be wrong. And I don't, it's just weird like that. So pay real close attention to where it says to round it. Okay, let's go back here. All right. So the 1.3 on my Z table, 1.3 is right here. It's 0.9032. So I did 1 minus 0.9032. And we have 0.0968. And that's the same thing that we got in our calculator. So it's all good. So it doesn't matter either way, whichever you prefer. Just remember that the Z table gives you the less than or equal to. Very similar to when we were using binom CDF and it gave you the less than or equal to. Z table's the same thing. Questions before we move on? Alrighty then. Sometimes we want to find a range of values. We absolutely can do this with a Z table. We absolutely can do it. This once again, I know I keep saying similar, comparing it to other things, but this is also very similar to when we were using binom CDF because the Z table gives us less than or equal to. So if I'm in my normal curve, and this right here is my Z-score of 1.02, which probably wouldn't be quite that far, but bear with me. And this is my Z-score of 2.94. I can find this area, this whole thing, and then I could subtract off this right here using the Z table. So I could take that whole area right there, then subtract off that little area. So what I'm going to do with the Z table first is I'm going to find both of these probabilities. Let me erase what I have. Sometimes I get excited and I just fill up way too much room. So what I'm looking for on my Z table, I'm going to look for the 2.94. I'm going to look for that first. So there's 2.9, 0, 1, 2, 3, 4. So that number is 0.9984. Then I'm going to subtract off the negative 1.02. Let's scroll down. So negative 1.02. Oh, I went too far. 1.0012. So right here is my negative 1.02. 0.1539. So now that I have both of those, I'm going to subtract off that tiny little piece at the end. Pop over here. Use my fancy calculator. Don't even need a fancy calculator for this. I get 0.8445. So that's the area under the curve between those two Z-scores. I'm going to show you how much easier it is with your calculator. This is what it's going to look like. Normal CDF. My lower bound, negative 1.02. My upper bound, 2.94. My Z-scores always have mean of 0, standard deviation of 1. That's what I'm going to put in my calculator. The lower bound, the upper bound, and then the mean and standard deviation. If you put that in your calculator, it's just going to give you this number, like wrap it up like a birthday present, and you're good to go. I'll give you a second. I see you're writing it down. Give me just a second here. All right, and move over. Let's go to the calculator. I'm going to clear all this. It's getting busy. Second vars, go to normal CDF. So this case, my lower, negative 1.02, my upper, 2.94. Always 0 and 1 for z-scores. And enter, and bam. That's the same number that we got. Well, if you round it, it's the same number we got. Questions so far? Say, but wait, what if I don't want to convert everything to z-scores? What if I have actual data values rather than z-scores? Do I have to convert everything to z-scores? You absolutely do not have to convert everything to z-scores. These ones are just saying everything that we already just said. So I'm going to move on. Okay. If you don't have z-scores and you don't want to convert them to z-scores, which I like never want to convert to z-scores, only if it's absolutely necessary, you can just use data values. So this is what it will look like. You would just do normal CDF, the lower, whoops, that's not a parenthesis. Lower bound, upper bound, then use the actual mean and the actual standard deviation, which probably are not going to be 0 and 1. So you can just use your data values as long as you also use their mean and their standard deviation. And it is so easy, and you don't have to convert it all to z-scores unless you're specifically comparing those z-scores. If you need to compare those z-scores, then convert them. If you don't need to compare them, this is it right here. This is your tool. So for between two values, you're going to actually have a lower value and an upper value. If you're doing less than or equal to, you're going to use your negative infinity number right there. If it's greater than or equal to, you'll use your positive infinity number right there. And that's it. It is just that simple. It really is that simple. We're going to do some actual examples with real numbers here. I think we're going to talk about giraffes. I think it's our second example though. Right. Oh, um, how come it doesn't give, I guess we didn't have an example of that. I think it's a just trust me thing. Um, I'm going to do something with, I'm going to do the IQ thing though. I'm going to just do that. So remember on the IQ, the mean, the mean was 100. The standard deviation was 15, and then we're looking for 120. So we're just going to do that. We're going to do less than or equal to 120 on our calculator. We should get the same percent. So we're just going to do that just to do a practice before we start working backwards. Okay. Second vars, my normal CDF. So I want to do less than or equal to 120. The probability of a randomly selected person having an IQ less than or equal to 120. So once again, negative 1, we're going to do the E, which is second comma, 99. Our upper is 120. In this case, the mean was 100, and my standard deviation is 15. So we're using the actual data values. Don't forget to use their actual means and standard deviations. Very important. Then I'm going to hit enter, and it pastes it, and this is what it looks like. And then hit enter. And I think it was because we round z-scores, it's slightly different, but my open math knows. My open math is smart most of the time. I think there might be one or two problems that is weird on its rounding in chapter 7. I think 7 is where we had an issue. We've tried to fix like the coding on it, but we can't get it to accept the proper rounding. So if you have problem that you are absolutely sure you've rounded it correctly and it's correct, if you send me a message, I'll take a look at it. Anyway, if you actually do have it correct, I will give you the points. And I think it's chapter 7 that has, it's one of the problems in chapter 7, I think, has that issue. And I don't remember which one it was. You'd think that I would write something like that down, but alas, I did not. But anyway, so there's that with the data values. Any questions before we start working backwards? Okay, pop back over to my iPad. All right. Sometimes we know the probability, the proportion or percentile that we're looking for. We know that, and we want to know the actual data values that go with that. Because if somebody says something like, you scored in the 98th percentile, but they don't tell you what your score is, and you're a curious type of person, if you know certain information, you know the standard deviation and the mean, you can work backwards and you can calculate that. You can do that with z-scores, or we can do that with actual data values. So we might want to know the height of a 2-year-old male who's in the 20th percentile, or you might want to know which which scores on a test separate the middle 90% of scores from the top 5%. So my calculator is a little extra fancy and it has something that most other people's calculators don't. So I'll try to show you both ways because I've noticed that probably 80% of my students don't have one of the features that I have, but I'll show you both ways. All right. So it tells you to draw a curve and shade the area. It is a really good idea to draw the curve and shade the area. So we can use the z table. You can use the z table and search in the body for the probability you're looking for, or we can use this function right here on the calculator. This is what I recommend. It's inverse norm, and I'll show you in a minute. It's located underneath normal CDF. You put in whatever the area to the left of your value is, and then the mean and the standard deviation. So the area to the left, and then the mean and the standard deviation. So you can find it as a z-score if you want. Now, if you're using the table, you're going to need to you're going to need to work backwards from the z-score. Or if you're using your calculator, it'll just give you the data value. I highly recommend just using your calculator, but I'll show you both ways, of course. All right, so let me move on over. Okay, a percentile means less than or equal to. So if I said you scored in the 90th percentile, it means that 90% of all people scored less than or equal to the score that you got. The 80th percentile means that 80% of all people scored that were less than or equal to you. So like when you have kids and you take them into the doctor and they say, "Oh, your child is in the 60th percentile." It means that 60% of all kids weigh less at that age, in that stage of development, weigh less than or equal to your child. So percentile, think less than or equal to that value. So the GRE is a score. It's a standardized test. It's normally distributed with a mean of 1049 and a standard deviation of 189. We want to know what the score a student has if they're in the 85th percentile. So it looks like this. Okay. So if I did 85%, it's somewhere over here. This would be 85% right here. And that means 15% of the people are here because 85% scored less than or equal to. So what's really cool is this is to the left of that value. So I can easily dig into my Z table and find the Z score that's at the 85th percentile. So I'm going to do that. Pop over to my Z table. So I'm going to, in the body of your Z table, you're not going to find the exact number. So right here, I see 80.8508. This one's 0.8485. This one's closer. So that's the one I'm going to use. So this Z-score is 1.0. 0, 1, 2, 3, 4. 1.04 is my z-score. I'm gonna write this down because I forget things really fast. So okay. So I know that I have a z-score of 1.04. So now what I need to do is find what data value is at, it has a z-score of 1.04. I'm doing it the hard way, and then I'll do it the calculator way. So remember the z-score formula is this. That's the z-score formula. I'm just going to plug 1.04 into the z-score table. I don't know what x is. I know the mean is 1049. The standard deviation is 189. All we need to do here is use a little bit of algebra to solve for x. Just use a little bit of algebra. Let's multiply both sides by 189, because that's going to cancel that out. Let's see. 196.56 equals x minus 1049. Now I can add 1049 to both sides. I have 1245.56 equals x. So I scored about a 1245.56 on that GRE. Bet you're looking at this saying, I really don't want to have to do this math for everything. Thank goodness you don't have to. If you love the Z table and you want to use it like this for everything, you go on and do that. Go right ahead. You are free to do that. But if you would rather use a fancy schmancy calculator, let's pop right over there and use it. That's not where I want to be. Okay. In your calculator, second vars, as I said, inverse normals right under normal CDF. It wants the area under the curve. So our area, 85th percentile, 0.85. My mean is 1049. My standard deviation is 189. Now this little is the feature that most calculators don't have. Most of them don't have this tail feature where you can choose right, left, or center. It defaults to left. So I'm just going to pretend it's not even there. It just defaults to left. Yours is, if you don't have this feature, left is the default setting. So I'm going to pretend that I don't even have that. And in this case, it would be left anyway. So I'm going to pretend that's not even there. I'm going to go down and I'm going to paste it, hit enter. That's not too bad because this rounds to 1245. And when I used the z-score, I got 1245.56. This is more accurate because remember our z table, it was slightly higher. On our z-score, z table, it was 0.8508. So that checks out that it's slightly off. But if I was rounding to the nearest whole number, they would both give me, well, the other one's 1246, but close enough. So 1245 it is, my z-score, that's my GRE score. And I highly recommend just use your calculator. The z table can be cumbersome, just use your calculator. Questions before we move on? Alrighty. I just did this. Oh, whoops, we're not even on there. Okay, this is my math there. I just did this with the Z table. I forgot that that page was there. So we just did that with the, whoops. We just did that with this right here. That would have been a little easier. And then here's my inverse norm. So inverse norm is just area to the left. Then a mean standard deviation. All right, let's move on. Okay, I would like you to try this one and use your calculator. I highly recommend using your calculator. The weights of giraffes are approximately normally distributed with a mean of 2,200 pounds and a standard deviation of 200 pounds. What would be the weight of the giraffe in the 75th percentile? So go ahead and see if you can do that on your own. Remember, it's 0.75 and not 75. I got 2334.898 approximately. How did we do? Good. Yay! I love it. All right. So weighs about 2334 pounds, 2335 pounds. Man, that is a heavy animal. All right. So I'm sure you want to know stuff about like what if they say, what if they say, greater than or what, I don't know what to do here. What if they go to the opposite direction? So we're gonna go right here. I want you to ignore all of this stuff right now. Hold on a second here. Ignore all of this. Oh, wait. I chose that. Okay. Okay. So let's ignore all of this. Okay. And I'm going to do some solutions here. See that? I'm being fancy. I'm just erasing the whole thing. It's not really erasing. I used a white pen. So it's known that the length of a certain steel rod is normally distributed with a mean of 100 centimeters and the standard deviation of 0.45 centimeters. Suppose the manufacturer wants to accept 90% of all rods manufactured. So we want to know the length of the rods that make up the middle 90% of all rods. This is where most of the mistakes are made. Questions like this is where most of the mistakes are made. I'm going to draw this. Oh, that is a very fat pen. We don't want that pen. Okay. I don't remember what, okay. So I'm going to draw this. There's my curve. So middle 90%, there is 5% up here, and there's 5% down here. So you are going to use 0.95 and 0.05 for your inverse norm. Now, if you don't have the special feature that I have at the bottom of your inverse norm screen, if you don't have that, then you need to do this twice. You need to do inverse norm twice. If you have that, then you don't necessarily need to do that. But if you don't have that, you're going to need to do inverse norm twice. Let me show you. I keep going the wrong way. So in my calculator, I was already on my calculator. Clear. I'm going to do inverse norm, second vars, go to inverse norm, and I want 0.95 because that's going to be my upper area. My standard deviation or my mean is 100. Standard deviation was 0.45. We're sticking with the left. Just leave that there, paste it, and I'm going to hit enter. So the value that represents the top, that 95% mark, is 100.74 centimeters. So we're going to do this again with the 0.05. If you're fancy, if you have a calculator that can do copy and paste, you can just use your arrow and arrow up here and paste and then just change a number to 0. If you have that, and that'll give it to you. If not, just go back into second vars, inverse norm, change this to 0.05. Keep it on left, hit enter, and you get the lower bound, 99.26 centimeters. So you're going to need to do it twice, but it's pretty fast to just go in and do it the second time. It usually doesn't take a long time. Now, if I was using the Z table, it'd be a lot longer process. but it's not still not terrible. It's just a little bit longer process. So I'm going to go back. So this you would be the manufacturer would accept all rods between 99.26 centimeters and 100.74 centimeters. Now, do any of you have the left, right, center, the thing on the bottom of your calculator? Any of you have that? No? Okay. So if anyone's watching this and you want instruction on that, let me know and I will talk to you about it. I'm not since nobody here is saying they have it, I'm just going to leave it. But if you want instruction on that and you have that on your calculator, let me know. Most students don't, so I just kind of ignore it. And I can be perfectly fine without ever using it. So it's not a big deal if you don't have it. All right. This was exactly what we just did, but they what they do is they're using z-scores instead, and I don't see the point of doing that because it's a lot more work. It's a lot more work using the z-scores, so just use your calculator. So that's the last of my slides. I would like to know if anyone has any questions. It could be about the lesson, could be about 7.1, it could be about anything. I am still working on giving feedback on the project proposals. I got the quizzes graded, but I haven't got the project proposals done yet or the hand-in homework. I'm working on it. Questions for the good of the group?
I have a question.
Yes.
So for this upcoming test and all future tests, will
Uh-huh.
it be open note as well?
Yes, all tests are open notes. My reasoning for doing that is that people find ways to be sneaky, and I don't want to penalize those who are being honest by when other people are being sneaky. So it's just easier to say, hey, just be open note for everybody. It just makes it easier.
That makes sense.
Yeah.
And will it basically look the same with as many questions as the last one and
They're
everything?
usually about the same length. Yeah.
Okay.
And I mean, I try to make them so that they all take about the same amount of time. So if it might have like a couple more like the quick questions that are just vocabulary, or like I know test three has some pretty has more math intensive questions, so I have fewer on there. So I'm trying to do time wise, make it about the same length.
Okay. Thank you.
You're welcome. Anyone else?
So the last problem,
This one?
yeah, this problem.
Uh-huh.
So they gave us basically to do the calculator function, to do it all on the calculator.
Uh-huh.
They gave us all the information, but just interpreting that like middle 90% is understanding that you're going from the 0.05 to 0.95.
Yeah, that's the important piece. That's where people mess up. People tend to say middle 90% and then just put point 0.9 into the calculator instead of 0.95 and 0.05.
Right.
You have, that's why drawing it is such a good idea. And it may seem like, oh, this is super simple. I don't need to draw it, but it's super helpful to just visualize it like this.
Okay, so then you're just finding the range. You're the answer essentially was like finding the range of lengths that the manufacturer would accept between the low length, the 99.26 and the 100.74.
Right. Exactly.
Right.
Perfect.
I'm just like going along sometimes and somehow figure it out, but then feel like don't really visualize the problem as
Mhm.
well as and then I'll get a similar problem, and there's definitely some interpretation kind of confusion at first.
Well, I'm going to pop over to the homework. I think it actually might be helpful. Let me pop over to the My Open Math homework real quick. And this could, I mean, it might be helpful, might not be helpful, but we're going to pop over and see anyway. So most of these are pretty straightforward, and they just tell you like between and all of that. But th some of them have pictures. So take a look here. you're looking for between the z-score of -2.1 and -0.4, or yeah, -0.47. So your lower bound will be this one, your upper bound will be that one, and this is not normal, this is normal CDF, not inverse norm. But this one right here, this would be inverse norm, and you're going to use 0.84. This would be inverse norm. Make sure that this one is -1e99 to oh wait, this is inverse norm. I just was going to do backwards. Inverse norm, but this one's going to be inverse norm, but you're going to do 1 minus what you get because this one's shaded to the right. So you will need to do 1 minus this. So if 0.85 up here is shaded, you want 0.15. And then you're going to do 1 minus because the top 85, I'm going to draw this because that might make it a little bit easier. Let me see if I can find a good a good empty spot in my notes that I can draw this. I'm just going to go back to the original page. Hold on. Okay. I'm going to draw this on my page. Okay, this is 0.85. Okay, so that one right there, I'm going to do it different. This is 85% right here. So you need to realize that this is 15%. So I'm looking for this value right here. We want to know that value because it wants to know the z-score for this region. So I need to use this instead. So I would use inverse norm 0.1501 because it's looking for a z-score. So even though it's shaded up above, it's just looking for the z-score at that point. It's looking for what this z-score is, and this z-score is at the 0.15 point, if that makes sense.
Mhm.
So since we default to left, you're going to have to subtract it from 1 first. Then this one's middle. This is where most of the people struggle. I'm going to draw this again and help you with it. I can tell you that of this entire assignment, this is the question I get the most questions about. Let me draw this real quick and then I will talk about it. You guys are lucky that I have like professional artist style quality drawings here. Well, I am a professional artist. I mean, I'm drawing right now, and I'm getting paid for it. So, okay. My drawing is very crude. My mean is down the middle. Okay. So what I know that 58% of my data is above the mean. This is my mean right here. 50% of my data is below the mean. So if I was thinking about the area of the curve, this is the 50% spot, correct? Right there. So if this middle is 28%, then, whoa, I did not mean to do that. Then this is going to be 14%, and this is going to be 14% because half of 28 is 14, which means this spot, I know it kind of sometimes messes with your brain. So I
Yes,
need to use inverse norm with 50 plus 14, use it with 64. 50 minus 14, use it with 36. Because that middle is 50%, you're going to need to add half of the area to 50 and use that spot, add or subtract half the area from 50 and use the other one. Does that make sense?
no.
And I'm not going to be mad if you still send me a message about it. I'm not going to be mad at all. I will still help, and you just won't get it spoken to you. It'll just be me typing it as best I can. And so that's for that question. I think that was the most complicated one. I think all the rest of them are not terrible. The rest of them aren't too bad. So just make sure if you get stuck, send me messages. Ouch, my cat just attacked me. So send me messages if you get stuck. I'll be happy to help you. Anything else while we're still recording? All right, I'm going to stop the recording.